Hi everyone, welcome to Cloud Ranger's Microsoft Azure training. This is the 2018 edition. I am Sean Ismail, a Microsoft Azure MVP. My contact information is below over there. So today is Module 1, which is Introduction to Azure. This is the Lesson 1, the Cloud Technology Overview. So I'm following the Microsoft official curriculum that I have showed you in my previous lessons. If you haven't viewed them yet, please go back and view them, and you'll get an idea what I'm talking about regarding the Module 1, Lesson 1, what does that all mean and how that sequence looks. Anyways, today is the Cloud Technology Overview. So I'm not going to get into much of what Microsoft Azure is very specifically, but I'm going to talk about what cloud technology is in general, a very good overview. I'm super excited about this lesson because this lesson is going to already get you started on understanding the terms that you see when you read about any cloud article or you go and read about any cloud technology. And this is not like just isolated to Microsoft Azure, but some of these terms are standard industry-wide terms. So I'm super excited to get started in this lesson because I think after this lesson, it's going to be something where you are just going to start understanding a lot of things that you read, specifically if you are very new to cloud technology or technology in general. Okay, and if you are already a veteran, maybe this lesson is not going to be as informative, but still, I hope that you find something in here. So getting a cup of coffee or some tea and get started. This is going to be a little lengthy session, and uh, let's get started. So cloud computing, it's a leading trend in IT right now. So if you haven't heard of cloud technology or this is the first time you're listening to the word cloud in IT terms or in the realm of IT, it'll be very strange, because everybody's talking about cloud these days. If you're at school or if you're already in the industry, you should already be hearing about a lot of this. So cloud computing has been around for a little while, so this is not something that will just come and go. It seems like it's here to stay in a very large way. So it's good to get understanding. It's good to get the understanding of what really all this means. So cloud technology, it's a major paradigm shift in computing. So every once in a while, something in IT comes along that changes everything and how we do our work. And that's how, or that's where cloud computing is right now. Okay, this is very similar to when virtualization came in for some of us folks. When it first came in, we are like really excited because it came in, started changing how we do our day-to-day work in IT. So it's a major paradigm shift. If I have to go and define cloud computing to you in very technology terms of ways, it can get very ambiguous. Like everybody I meet, when they talk about cloud, their understanding is quite similar. But if I ask them to define it, including myself, it gets very ambiguous. I mean, it gets very confusing. So I'm going to try my best to actually tell you what really means in a very simple way. Okay. So cloud computing is all about layers of abstraction. So when I say layers of abstraction, if you come from a virtualization world, it will start making a lot of sense to you. But if you don't get it yet, don't worry about it. But it's all about layers of abstraction, and it all uses some sort of virtualization technology. It doesn't matter if it's Microsoft Azure or AWS or whoever. Okay, so you have to also know Microsoft Azure is not the only major player out there who's doing cloud computing. There's Amazon's AWS, there's Google Compute, and many others. I mean, there are a lot of other vendors who are trying cloud computing or being a cloud uh, computing provider or technology provider in some way or the other. Okay, so why, and more importantly, how did you get here? Like, how did we get into this whole cloud computing thing? So for this, it's going to be a little bit of a story. I'll give you a background on how we got there. Okay. So back in the days, and sometimes even today, we have the on-site systems and networks. Okay. So everything that you see in this diagram used to be a physical server. There were physical computers, physical servers, routers, switches, gateways, firewalls, and they used to be connected to the internet. We are talking about servers like domain controller, file servers, FTP server, web server, router, switches. They used to be all physical servers. We typically call them now the on-premise systems because they used to be located on-premise. Means they used to be located where basically you're working. If you're working in an office, they would have a little bit of a room or something which was very well cooled and dust proof as much as possible, or it could just be a shelf in some corner, but there used to be physical servers that were presented there. So this is how a lot of IT veterans started back in the days. I mean, I'm not going to say that these kind of things are not there today, but they look very different and they function very differently. Back in the days, like if you look at this little diagram over here, all of these would be one single server with one single functionality, right? One would be a domain controller, one would be a file server, one would be a web server, email server, or maybe have one server who would have multiple roles, but this to be in general just one physical server each for one of these roles, okay? So they're still called the on-premise systems. Anytime you hear on-premise, means it's located on premises or it's located somewhere else, but it's all physical hardware. And that term is very common in the industry right now, and you'll hear about it more as I speak more and get into these lessons. So people used to function that way. Organizations used to function that way. Then what happened is maintaining those racks used to get complicated. Like they would actually, I mean, you'd start having multiple servers. I mean, you'd not have an organization with just 4 servers. You could probably have 40, you could have 400. And what they started doing was like they started creating their own data centers in specifically like in a location in that office or in a different place. So what they started doing eventually is when you had like tons and tons of servers, like you look at this diagram, I mean this picture here, they started going into something called as data centers. So what data centers used to be is, like I mentioned in these points here, a dedicated space for housing infrastructure. Those large data centers, which used to have thousands and thousands of servers, you could literally go over there and pretty much rent a cabinet or a cage or different shelves like this where you could go and put your servers in there. So if this was your organization, this all could be your servers and you would go and rent this space from the data center. Why would you go there? Well, it was a dedicated space. The data center would actually provide you high bandwidth internet access. They would provide you the redundant power source, dust-free controlled environment. So if you went to one of these data centers, they used to have, multi-million dollar, controlling the dust, devices and create that environment which would be dust-free. It used to have very efficient cooling and air ventilation systems because, as you can imagine, all these servers would produce a lot of heat, and you needed some crazy cooling and air ventilation to maintain thousands of servers if it was a large data center. It would provide you high physical security, so you could not just walk into that place and start meddling with the servers. There would be a lot of protection, access, and all that things you have to go through to get there. And some of these data centers would actually provide you inter-data center networks to provide disaster recovery. So if something happened to this data center, and let's say it was in flames, you'd have redundant data center somewhere located that would provide you your disaster recovery or the DR site, what we used to call it. So maintaining something like this, just for your organization with all this stuff, it would be very expensive. So, like I mentioned, people used to go and rent this space out or cabinets out or cages out from professional data centers who's to just provide the service and say, you can come and do whatever you want. And this used to be pretty expensive. I mean, um, building, like I said, building this yourself would be hard. So you just go to a data center to do this. And regardless of that, you used to still pay for that location. So it used to be expensive depending on how many servers you have. I'm not going to get into details on the cost modeling of data centers. Back in the days, they would just basically look at this and be like, all right, you have like about 5 or 6 racks. We'll charge you by racks. Later, it got more sophisticated. They started, when you started getting those blade servers and everything else, they started charging by power, which is quite common right now. So it's a combination of different things that data centers still till today charge you on getting this. But know this, that going into a data center, it would provide you all these benefits that I've listed on this here and more. And it is to work out for most people. These are all physical servers, and it was pretty good. So data centers, like I mentioned, when they first came out, the concept of managed services started there. And I'm not going to say concept of managed services completely started there, but it started becoming very popular. Like, so what the data centers started saying was like, okay, I'm just renting you or leasing you that space for you to go put in your own servers. Means you still have to manage it yourself. You used to take a short trip to the data center if it was located near your organization, or doesn't matter, whatever. You'd go, you'd physically hook up the servers, physically make sure you have network connections and everything. Means the physical everything, you have to maintain it yourself. The other thing that used to happen was that you would try to get remote access to those servers. So you're not going to go and sit in a data center every day. I mean, some of those data centers would be really freezing because they used to maintain all that cooling and air ventilation. So you try to get remote access to those servers and do all of that. So what data centers started telling you is that, since you put all this stuff over here, let us manage that for you. So that means you concentrate what you need to put on those servers. We will do the physical hookup, we'll do the network connectivity, we'll do all of that for you. We'll provide you the remote access with your username and password, and you can take that and do whatever you need to do. Means you don't need dedicated folks to go maintain those hardware if the motherboard got fried, or if the memory stick broke or anything. You don't have to do that. Let us do that. Okay. All you do is host your server roles. Means you get your, let's say, Windows Server 2012 or 2016, you can just go in there, install your software, and take it from there. Don't worry about the underlying physical infrastructure. They would provide LAN extension if required. So if you wanted to connect to the data center directly from your satellite offices, some of these used to provide those LAN extensions. And what this did, like I mentioned, was that it gave you all the benefits of a data center because your data center is already there, but it also provided you the physical or the infrastructure administration. Okay, that means that you didn't need administrators physically to go and do all of this stuff. Their people will take care of it. So if you have thousands and thousands of servers, it made a lot of sense for somebody else to take care of that. Obviously, they charged you for it, but then you didn't need that many people on your team with all those expertise to go and maintain that. This is where I want you to remember the term tenants started. Okay, so a data center would provide you all this, and they would have multiple tenants. A data center would just not only serve your organization, it would have multiple organization, and the term tenants started getting used quite a bit because a data center could have like even thousands of tenants depending on their capacity who would be their customers. But this is where the managed services thing started coming in. Your services started getting managed by other folks. And these are all very important concepts, whatever I'm telling you, in very high level. I mean, some of this might be so high level that may sound accurate to some of the veteran IT folks. I mean, inaccurate to some of the veteran IT folks, but that's what built cloud computing, and I'm slowly getting what that means. Okay, so while that was happening in the IT world, the virtualization just came in. What virtualization started doing is that, hey, okay, you have this one physical server which has one role on there. For example, it's a file share server. It just was one physical large server like this. I just took a picture of a Dell server here, but it could really be any server from any vendor. And all you do on that server is do a file share. That means this whole physical server with a lot of resources would just sit idle when it didn't have much to do. So in very high levels, most of you probably already know virtualization and what it really does. The concept came in that, hey, we'll take one large server, we'll provide isolation through virtualization, through a hypervisor, and you could have multiple logical servers on one physical server. That means you could really optimize the utilization of this physical hardware. Okay, so that means you could have multiple servers or virtual machines or VMs that were running on the same physical hardware. So if you had like 10 servers with all separate roles, maybe you wouldn't need 10. You could probably consolidate that to about 3 or 4, depending on the hardware size, and you could put all of them in together. Okay, so it started making a lot of sense to do that. And most organizations now use virtualization because it just started becoming cost effective and easier to manage rather than having thousands of servers for large organizations. They started saying that we are going to consolidate through virtualization and make things easier to manage, or less of things to manage, which would in general be easier. So virtualization then suddenly hit I mean, it hit all organizations at various different times, but they did. So let's revisit the data center managed services. So if you recall in a couple of slides um, back, I mentioned that data centers started hosting physical servers themselves and providing that service. So what data centers now started doing is like, let's get virtualizations to its maximum. So what I'm going to do is I'm going to have a lot of physical hardware and I'm going to have a lot of virtual machines on it. That means, more profit. I'll make more money because if I have an organization who comes and takes 10 servers, means one entire rack, because each server was a role by itself. Now I need to only give them three, and I can still do all of that. Means the rest of the rack or rest of the space I can put in other servers for other organizations. So as you can see, this was like the density that was increasing because they could fit more in together. Okay, and it became quite cost effective for them to do that because a lot of organizations were now looking for, data centers were already expensive. They're looking for cheaper options, and they started saying, okay, rather than 10 servers, I'll give you three, so it's going to be cheaper right now. So they started making money with the economy scale and everything else. So this is where it got quite interesting. So for example, let's say we have 6 servers here, 4 over here. So there are 24 servers here. Back in the days, if these physical servers were for one organization, it would take all this space. Now, you could have multiple tenants here, and I'm going to start using that word tenants here. Now, with virtualization, they said, hey, rather than 24 servers here. I can look at how many servers I can already fit here. 1, 2, 3, 4, 5. That means 10, 15, 20, 25, 26. So rather than all this space, I could fit this organization with only, this 4 or 5 servers. That means the rest of the stuff I could sell to other tenants or other organizations to host their stuff. Means I have lesser hardware, I have more tenants, and I'm giving them and I'm charging them a certain amount of money. Means I'm definitely making a lot more money with the existing hardware I have here. So data centers took a lot of opportunity out of this. Different data centers, or they used to call themselves different names. Like some of you already probably are familiar with VPS, virtual private system, or whatever they used to call that VPS. So you could just go and buy one virtual machine for a very small amount. Whatever you had to pay from from a data center like this or a provider like this. Okay, so this is where things started getting interesting. This has been out there for a while right now. People have been doing this for a while, and I have not even touched cloud computing yet, right? This was not even cloud computing. People who just go and buy virtual machines from these data centers or these service providers. Okay, so we know about this, and I'll get into cloud computing in a bit, but let's start it with cloud services and what cloud computing definition actually is. If you remember my, the first couple of slides, I said that, or I mentioned that, defining cloud computing in technology terms is very complicated and very ambiguous. So this is actually a definition that I took from NIST. It is the USS National Institute of Standards and Technology. It's quite common here. This is their take on what definition of cloud computing is. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. Example, network servers, storage applications, and services that can be rapidly provisioned and released with a minimal management effort or service provider interaction. I don't know about you. This is a very complicated definition for me. And by the way, that's the PDF over there, and that's the link where I got this from. Let me show that to you. If you go to that PDF link, I'll put that in the links. It's a very nice document from NIST definition of cloud computing. So they have the definition over here. They also talk about the different deployment models. It's a very nice document for you to at least go through once to understand what their take on cloud computing is. But anyways, this is a very complicated definition. For me, cloud computing really means that, if I go to this previous slide, that a provider like this will provide you unlimited computing based on utilization, which could be storage, network, computing, anything else. This will make it very easy for you to provision without really contacting them much. It should be self-service, sort of, and you can do it in different regions around the world. For me, that's what cloud computing really is. Okay. The model that I'm showing you, or the slide that I'm showing you over here, back in the days, it was there, but it was not easy to do. For example, you probably had to contact them through a form, through some application, or calling them up and say, hey, I need this many virtual machines. They will take their time to actually go and slice it and dice it for you and tell you, okay, it's up and running. They would do the networking. So the flexibility was not there. Cloud computing in general, very high level, is this similar concept, but you just have so many ways to do it just by yourself with very little intervention from these providers to do this. That's my take, or that's my idea of cloud computing. Okay, and I'll tell you why is that the case. So there are 5 characteristics of cloud computing, and this is actually taken from the NIST document that I was showing you as well, and it will start making a little bit more sense now. So for cloud computing to happen, or to call it, or it to fall into the definition of cloud computing, first it has to have on-demand self-service. So the consumer, that's yourself, you should be able to provision resources as needed, whenever, without much interaction with the cloud service provider. It means you should be able to do this yourself. You should be able to go spin up your network, spin up your storage, spin up your virtual machine, and do it yourself. So this will be very similar to how virtualization most likely in your organization is happening. If someone from, let's say, accounting comes and says that, hey, we need to put this application and I need 2 virtual machines. If you're already using virtual machines in your organization or some sort of virtualization, you already know that how easy it is to go create a couple of virtual machines, because the virtual network storage and all that, you can just slice from there and make that today. So in a cloud computing world, you should be able to do this on-demand self-service, and there should be a lot of abstraction. You should not have to worry about how the networking, switching, routing, storage, provisioning in storage area network, and all that is happening. You should be able to do this on-demand self-service. It's a requirement for it to fall under the cloud computing realm. Broad network access is the second characteristics of cloud computing. Means you should be able to access these cloud services from anywhere and from most devices. And I'm not talking about, accessing a server. Means if it's like a web server, you can go from, you can go to the website. No, I'm talking about that you should be able to access the cloud service where you actually go and provision this stuff from mostly anywhere. It should be accessible anywhere. And most cloud providers provide this through some sort of a web portal. So that makes sense. The third characteristic is that of a resource pooling. Means there's multi-tenancy. If you recall that diagram, or that that image that I showed in a couple of slides, back in a couple of slides, there should be resource pooling. Means there could be thousands of servers, and it will go and provision the resources only for you, and other organizations should be able to go and share those resources and everything else. So there should be a resource pooling there. If you want some, like, if, let's say you want 1 terabyte of storage, it's going to be 1 terabyte of isolated logical storage for you. But if I also want to go and get 5 terabyte of storage, I could be actually accessing their storage area network and their storage pool, and cut or slice my storage out, right? So the multi-tenancy comes here quite a bit. It means all these cloud service providers out there, they all take every resource they have and keep it in a pool for different organizations to cut and slice and get their part of it. And they pay, and those organizations will pay how much utilization they're doing or how much resource. If you take 1 terabyte, you'll be paying a certain amount. If I'm taking 5 terabyte of storage, just as an example, I'll be doing something else. I'll be paying something else. If you have 5 virtual machines and I have 10 virtual machines, we'll pay different. But end of the day, all the resources are pulled into like a single data center, or different geographical location and all that, and I'll get to that in a bit. In a bit. But that's one of the characteristics that you need. The fourth one is rapid elasticity. What really this means that you should have the capability of scaling in and scaling out, as your workload intensifies or reduces. So, for example, let's say that you need 5 web servers typically for your website to function. You should be able to scale out. Let's say you have a campaign going on or something is going on, you're selling on your website, you know that there's going to be a lot more traffic, so you don't need 5, you need like 20 servers for this 2 weeks when you're having that sale on your website. So rapid elasticity means that you should be able to go and spin up more virtual machines, or utilize more resources because of the virtual machines, like more storage, more networking, and you should be able to do that. So that it's called elasticity, right? It's like elastic that you can pull and let go. It will shrink and expand based on your need. So we'll definitely get into that huge concept of rapid elasticity when we get into the further lessons how you do that. But that's one of the characteristics that cloud computing should have. And measured service. So cloud computing is not only about how many virtual machines you're running, it's also about the resources that are used for it. A virtual machine takes a storage, you have to have network, you have to have a lot of other things, firewalls maybe. So all of this service, you should be able to monitor, control, and report individual resources to the consumer. Means that the cloud service provider will have to tell you what is your utilization. It's like a very itemized bill. So if you have a cell phone, you know that every time you make a call, depending on where the call is, what the duration is, you are charged a specific amount. So with cloud computing, depending on how much computing resources, CPU, RAM, storage, network you're using, every little bit is it's metered, means that everything will be calculated separately, and it's all based on usage. If you're using it for 1 hour versus 5 hours, you get charged like that. So it's a very utility model, or and it's all based on your utilization, how much you do. Okay, so these are the things, or these five characteristics, at least NIST finds that if you need these five characteristics to be a cloud provider, if somebody is not providing you that, they're not necessarily a cloud provider. They're just providing you some resources somewhere. So if you look at, this slide, that model has been there for a while, but it was never really called cloud because either one of those five characteristics would be missing. Either you could not self-provision, or you probably did not have the elasticity. So for example, let me give you an example here. If you had, let's say, like about 25 or 30 servers here, and all of a sudden you needed, I don't know, another 10 servers, you probably couldn't just go and do it yourself. You'd probably have to pick up a phone, call someone and say, hey, I need 5 of them. 10 virtual machines. They would have to figure out a way how to give it to you, make sure that they're giving it to you in the network where your existing stuff are. Maybe this was one of their cabinets, and if this cabinets ran out of servers because other tenants were using it, they'd put you somewhere else, and they would have to figure some crazy way to network between your this servers and that servers. With cloud computing, you should be able to do all of these things yourself, and you should be able to do that quite easily, self-service way. So I've had people who have argued or had very good, reasons to say, hey, cloud computing has been there for a while. It has been and it has not been, and it's mostly it has not been because one of those five characteristics were missing. I recall I had a bunch of virtual machines for this organization once we purchased from one of these providers, and I remember they used to be billed like per virtual machine. So you used to pay we used to pay a couple of $100s for one virtual machine per month. But that's it. They would just have this random number, which they thought was the right thing to do with combination of power, with combination of storage. They said that it doesn't matter if you have one of these virtual machines, you are going to pay this much. In cloud computing, that's not the case. In cloud computing, it's not only about the CPU, RAM, and storage. There is a lot of other things, like they will charge you for networking, they will charge you for storage, all separately. They'll charge you for a firewall, depending on how many rules you have in the firewall. In certain way, it's actually pretty cool. A lot of people might think that, hey, doesn't that make things complex? Not necessarily. It actually makes it very cost effective. I'm going to only pay for a virtual machine. Doesn't matter. If I'm not going to use it and I turn it off, I don't want to pay you for the rest of the month. If I have 5 machines today and I need 10 tomorrow, making it a 15, I don't want to, just pay for only those 2 weeks when my usage on those web servers, for example, will be high. I only want to use it, let's say, per hour basis. So this utilization is actually a pretty good thing to do. Okay, so without getting into too much in depth over here, those are the five characteristics that make it a cloud computing. Now, what are the advantages of cloud computing? I could actually list way more here, but these are the four I sort of thought were the most important advantages. So it's a fully managed data center. It's not a data center of your own. We had that concept before, but right now we're talking about it's a fully managed data center. There's nothing in there that you have to manage in that data center. Literally, you're just going and spinning up a virtual machine and you're good to go. Every underlying thing, and this is where the abstraction that I kept talking about comes in, it's all abstracted from you. You don't have to worry what it is. You don't have to worry about the power, networking, cables, nothing, no hardware. It's all maintained for you. And that is one of the most important things in cloud computing. For you, really accounting and finance folks, this is actually no longer a traditional capital expenditure. So this is not a capex model. So you don't go and talk to your organization or your unit or line of business owner and say, hey, I will be needing this 20 servers next year and so much storage for additional storage for doing our business or network switch and everything. This is no longer a capital expenditure. This is more of a model of OPEX, which is operational expenditure. So you are only going to go and do this based on utilization. And your utilization from month to month may vary based on your requirement. So basically, you're not purchasing those hardware and paying for it when the project is only going to, get started or really go live at the middle of the year. So you're not just buying something and keeping it over there. This has created some problems, like how do you budget for this, right? So I don't want to get into so much details. There are still ways you can make your OPEX look a lot like CAPEX from a budgeting point of view. Like you can understand, okay, basically I need some stuff and this is the pricing for this, for these resources. And you can make this a CAPEX model with some upfront commitment. But there's ways to actually do that budgeting. But what I'm trying to get across here is that it's no longer a CAPEX, it's more of an OPEX model. There's a low operational cost associated with all of this. So, you know, if you are, let's say, a startup, and as a startup, you are going to have a bunch of web servers, database servers, I don't know, mail servers and all of that. Back in the days, you'd have to, like I mentioned, that you have to go buy physical hardware. I mean, not even back in the days, even today, you have to go buy hardware and you have to do virtualization on that. You need people who will have to have those kind of expertise to do that. So you would have higher operational cost not only from human resources, but you would also have operational cost on maintaining all of that, right? At some point. So with cloud computing, since most of the abstraction is in place and most of the things are managed for you, you don't have to worry about the operational cost for all of that. So in general, it makes your operational cost a lot lower than what it used to be. Okay, so that all results into a better speed or time to market. So if you're like an application developer or you are a business who's just creating this crazy website or this crazy app, you have a better speed to market. You don't have to get your hardware, provision them, put them there, make sure everything is up and done right, load balancing, security and all of that. So you can actually get your product out to the market more faster than what it used to be. You can only concentrate what your business is and not worry about other things. So I find this like the most the advantages of using cloud computing. I mean, definitely, if you think there are a lot more, put them in the comments. Let other people see why you think cloud computing is better. But I think these four are the selling points for me that I tell most people why there's a lot of advantages of getting into cloud computing. Okay, so now let's get into some details of cloud computing. Now that we understand, I'm hopefully thinking that you understand a little bit of what cloud computing is. So cloud deployment models is the next thing I want to talk about. If you come from a development background, don't worry, this is not the kind of deployment that's like a traditional software deployment or application development now. They call it deployment models, but these are really more of how this infrastructure and where the infrastructure is located. That's how I look at it from a deployment models, and I'll tell you in a bit what that actually means. So the first cloud deployment model, by the way, let me go back to this previous slide. I'm showing three models. There are people who probably argue like NIST has this fourth model or whatever, which is like a community cloud or whatever. But I think that most of the cloud computing we talk about falls in the private, public, and hybrid model. So let's get into the private cloud. So what is the private cloud model or the deployment model? I'm trying to ignore the word deployment here. What is the private cloud model? And I'm pretty sure some of you heard about private cloud. So private cloud, it's exclusive used by single organization. So your organization could have a private cloud. Okay, it could, or it may comprise of multiple consumers, means that it's a single organization but different business units, sales, marketing, accounting, IT, whoever. There are multiple consumers who could be using this cloud. It may be owned, managed, and operated by the organization or a third party. That means just because it's called a private cloud does not mean that you own it. A third party can own it and manage it for you. And I know that sounds a little confusing there, but hang in there. I'll tell you what that means. The fourth one is organization has full or maximum control. Okay, that means if it's a private cloud, it's you have it in your organization's data center or in your office somewhere where you call it your little data center. Um, you may have full control over it, or it could be a third party, like I mentioned in the point three, was that it could be a data center who provides this service to you. So you might have maximum control over there. You may have access to those, virtual machines from a bare metal point of view, or you could have access to the hardware itself, right? But in a different data center. And the fifth one is that you may already be functioning in this deployment model today at your organization. So all you folks who have stuff on premises or have stuff that you maintain in doesn't matter some data center somewhere, that's actually a private cloud. Means you can go in there, do whatever you need to do, given that you have a bunch of, let's say it's a virtualized environment. Let's say you have, 5 or 6 virtual hosts. You can go and create your virtual network, virtual machines, storage from a storage area network or something like that. So that's why I mean that you may already be functioning today that way. Okay. And this data center does not have to be yours. Very few organizations have their own data centers. So, this could be a data center, that you go lease or take, like I mentioned back in, we used to have cabinets or cages, whatever. It could be one of those spaces as well. That's what private cloud is. Okay. And it's good to remember that you are probably in a private cloud today in your organization if you're one of those organizations who have its own, hardware and everything else. So that's what private cloud is. And I want to talk about public cloud. This is where Microsoft Azure or Amazon AWS or Google Compute really come into play. Okay, it's provisioned for open use by general public. So the distinction between private and public cloud is in a private cloud, it's really for this one organization to go and do its own thing. With public cloud, Microsoft does not care who you are. Anybody can go and use any resources that they have to provide. Obviously, you have to go sign up and you have to set up billing and all that. But you know what? It's really open for general public. You can actually go spin up your own Azure subscription and have a virtual machine in 10 minutes right now. Okay, this is where public cloud and private cloud distinction comes in, like I mentioned. It's multi-tenant. Like I said, the word tenant will keep coming up. Multi-tenant means that Microsoft has, you know, many data centers right now. If it's one of those data centers, it's not just for you, it's for a lot of other, I mean, any organization who really wants to go in there and spin something up. So it's multi-tenant. A lot of people are hosted there. It may be owned by any type of organization. Like I mentioned, you don't even have to be an organization. You as an individual can go right now and create a virtual machine and start doing whatever you want to do. So as good as having how many servers, create your own labs, which we will be in this forthcoming lessons, and you'll notice that it can be any type of organization or individual who can do it. Public clouds host the infrastructure and services for multiple organizations. And I keep saying that like, public cloud, they will host the infrastructure, they'll hold the service for any organization. Organizations have typically less control of the services. Okay, so you have to understand one thing here. When we bring in abstraction, that means that you are actually having lesser and lesser control about the stuff that actually hosts that virtual machines or those cloud services, right? So that means you do not have access to those physical machines there. You do not have access to the physical hardware that is, let's say, there for your firewall or security or storage, networking. You don't have access to that. There are ways you can, like I mentioned, Microsoft has many data centers. There are ways you can actually put it in a certain region. So, for example, in Canada right now, they have 2 data centers, one in Toronto and one in Montreal. I mean, you have control over where you want to put your, where you want to consume your cloud services from. But that's about it, though, right? I mean, you don't have access to anything else. So there are compliance implications here. So some of you security folks or veteran folks, you know what I mean. So for example, right now this whole data privacy and security thing is going on. A lot of organizations in Canada do not want to host stuff that is anywhere else besides Canada. It has to be in a Canadian data center. It has to be somewhere else. I mean, it cannot be somewhere else. I know, Europe is going through this GDRP right now, where data residency is a very important thing. That okay, yes, you are taking my information. Which server are you putting it on? Where is the servers located? Where are these things located? So compliancy becomes a thing there. I mean, if you're brand new into this technology and everything, just remember there are compliance implications because you have very less control over the physical hardware that's there. But this is something you have to think about when you are working for a large organizations doing cloud computing that were there. But basically, the distinction between public and private cloud are based on these things, right? Now, hybrid cloud is very interesting. The reason hybrid cloud is very interesting is like it's a mix of basically your private cloud and public. So what happens here is that if you're an organization, like I mentioned, that you are probably already on private cloud if you are in a data center by yourself and doing everything there, you're not going to take the whole thing one day and do a lift and shift and go to the public cloud. I mean, that will just be it's just too much work. There's a lot of planning, a lot of architectural consideration, implications that you have to think about. So it's not going to happen. So basically, a combination of these two is most likely where most organizations will end up in. Okay, it's a good way for organizations to try the public cloud as well. That okay, I have a bunch of servers over here, but I want to now get into the public cloud and get a bunch of servers or consume some cloud services from there. Try it out a bit, maybe have a VPN tunnel between the public cloud and the public cloud so my data can flow internally in a secure fashion, but I'm not going to take everything I have to then put the public cloud. This is where most of the organizations who have been there for a while will kind of get started. Now, if you're a startup, it's sometimes called born in the cloud thing. If you're a new business, you probably don't even have any private cloud stuff. So you could probably start right away and, basically your business gets born in the cloud. So then you don't have to worry about it. But not many large organizations that are there are going to do that or will end up completely being in public cloud. They'll always have some sort of a fashion of stuff that's there in the private cloud. Like I mentioned, this could very well be for security reasons. This could be very well for compliancy reasons. This could be very much a lot of organization like, large banks, large financial institutions, government organizations. They're just not fully comfortable on taking all data and just putting it in the public cloud, even though public cloud now has multiple certifications and compliancy that they go through, and they may suffice, but a lot of organizations just have a policy of not putting things completely in the cloud. So hybrid cloud is where you'll most likely end up at. So next time you hear somebody says hybrid cloud, you know that this is basically a mix of private and public cloud. Okay. Now I'm going to move into something a little bit different right now. Um, Talk about the cloud service models. You'll hear this quite a bit. These definitions are important. Get used to them because, like I mentioned, this whole lesson today is all about terms and definitions that give you an idea on what you are getting into cloud computing. And we are going to follow that in the subsequent lessons where I think this will be my last lesson where I'm going to talk about anything that's neutral, or this is going to be anything that's like common to any cloud platform. Okay, anything after this lesson is actually going to get into much deeper in how Microsoft Azure calls their stuff and get more specific. But these are the things you need to absolutely understand cloud computing. So let's talk about cloud service models. So we just came from the cloud deployment models or just cloud models to to the service models right now, and talk about the three service models that really makes the cloud thing happen, right? So cloud services generally have three categories. You may be familiar with some of this, or maybe not, which is okay. Software as a service, or SaaS, is something that has been there for a while. This is the highest abstraction when it comes to cloud services. Let me tell you how. So technically, you are just going and signing up for a software application. You're not doing anything. You forget even the physical servers and all that stuff. You're not even doing anything virtual. You're not even going and installing any software. You're just going and consuming a service. That's why it's a software as a service. The consumer of this app does not maintain any software or hardware, like I mentioned. It's a full abstraction. These examples you probably know for years, like if you go sign up for Hotmail, Gmail, Office 365, um, you know, Salesforce, uh, all this stuff, you're basically just signing up for a service. You do not care how this infrastructure is built. You do not care how these virtual machines are all, designed, where they are located. You don't even care how the software is, configured. You just go and get that service. This is very important because software as a service is the highest abstraction when it comes to cloud computing. Okay, so remember that software as a service. There's a lot more example there. I have just put this 3 and 4. When we get into Azure, I'll talk about where the things are actually software as a service. It will start making more sense then. But this is something you should be very, very familiar with. Okay, the next is platform as a service, or PaaS. This is basically a collection of various cloud services that the consumers can consume and build custom solutions on. Okay, so this is one layer of less abstraction than software as a service. Means you're not just going and signing up for a software. Let's say you want to build a website. These are the things you don't have to do. You don't have to get the physical hardware and configure and do all of that. You don't have to go even and spin up a virtual machine, put IaaS or Nginx or Apache, whatever the web server needs to be. Those all things will be done for you. So basically, someone is giving you IaaS and saying, go deploy your web application, or somebody's giving you Apache Nginx and say that, hey, just deploy your code and build your website. Don't worry about anything underlying that. So they are giving you the platform. Okay, you do not have to worry about anything else that's underlying that. It's one layer lesser than software as a service. In a software as a service, they would also, in this example, I mean, that's not how it's going to be. In this example, your website will also be given to you, right? But in this one, they're saying that go put your solution and don't worry about anything else. It's one lesser abstraction. But it's still, there's a lot of things, underlying stuff like hardware, operating system, web server, for this specific example that I keep talking about. You don't have to worry about that. It can be used for rapid development work. Let's say you're a web developer. You don't know servers much. I mean, you don't care about it much. You really care about your web application, your app that you're building, right? You need some control because you need to deploy your solution there, but you don't need anything more than that. You want to concentrate on just coding and doing your work. This is where platform as a service is a very interesting one. Okay. So that's the second model. And the last one is infrastructure as a service. It has a little bit lesser abstraction than the first two, and I think infrastructure as a service is more like the newer service model that came out when cloud computing became a very important thing. The other two, some people can argue that, hey, software as a service used to be there before. Yeah, obviously, we signed up for Hotmail mid 90s, at least I did. I mean, that has been there for a while. People has been doing that for a while. Platform as a service, I know that there were a lot of people, I mean, service providers even today, where they'll provide you that for web servers or email servers and everything else, where they're like, hey, put your solution there and we'll worry about that. I think the third one is where cloud computing really came into being, right? So infrastructure as a service, and this is important you understand this term, infrastructure as a service. So basically, you're creating infrastructure in a service model, right? So like I mentioned, this provides the consumer the maximum control on the environment. Lower abstraction means higher control. And consumers can create virtual machines, virtual storage, network. So this is very much being like in your own data center, except that you don't have to worry about the virtualization up to the virtualization part. You don't have to worry about the physical hardware. You don't have to worry about networking and all that. You are ready to just go and create a virtual machine and don't worry about the resources there. You don't have to worry if you're running out of storage or running out of networking ports, nothing. You're just ready to go and create a virtual machine. This is maximum control because you are building the virtual machine. Only the operating system will be given to you. So if you want a Windows box or you want a Linux box or whatever, Ubuntu, well, it is part of Linux, but if you want Ubuntu, CentOS, Red Hat, you can just ask for that and the virtual machine will be created for you. It's a fresh virtual machine. You can go and configure that. You can go put your application. You can go put your configuration. You can go and do a deployment. So that means you have the most amount of control compared to the SaaS model and the PaaS model, right? Because if it's your virtual machine, you have access to everything over that. The resources can be provisioned and decommissioned on demand. Means if I want right now, I can go to Azure and spin up 100 virtual machines. That's the kind of power cloud computing gives to you. Obviously, you'll get charged for it. I suggest you don't go and do, you know, 100 virtual machine if you really don't need to. It's not only even 1,000. I mean, 100. You can go up to 1,000, 10,000, depending on your demand. You can create them, provision them, and decommission them. That's what makes this so powerful. Okay. This is very similar, but by the way, IaaS or infrastructure as a service is very similar to how admin functions in private cloud, like I mentioned. If you already have virtualization in your organization, if somebody wants 5 virtual machines, you could do, you can go and just give them 5 virtual machines. As long as you worry about the resources in private cloud, you can keep giving people all the resources. In public cloud, that's the thing. You do not have to worry about the physical resources. You have 5 or 50 or 500 or 5,000. You don't worry about that. Microsoft will keep providing you all those resources. Okay. And infrastructure as a service, that's what's the most interesting thing in the cloud, because right now you can go literally watch a couple of these lessons I have and create a data center with all the stuff you have in your organization if you have the time to go and do that. So that's what makes a, a I mean, this cloud service model, that number three, infrastructure service, it's the real thing about the whole this cloud computing thing. Okay, and this is, like I said, it's not only focused to Azure. I mean, it could be in Amazon AWS. You can go and do the same thing. And I think that pretty much concludes this lesson. Like I mentioned, that go back, listen to this couple of times, read about it, after knowing these terms, hopefully, I'm thinking that you can get it started on any cloud platform. Let that be Microsoft Azure, which is my focus. You could go do Amazon AWS once you understand this stuff. And like I mentioned before, that you will start feeling good after watching some of these lessons, because now you should be able to read any article or read any documentation and be like, you know what, I think what they're doing there is most likely infrastructure as a service. This looks like a public cloud thing, not a private cloud thing, or the solution that I'm reading in an article, it's a hybrid cloud solution. My goal of this lesson is that I'm hopefully able to provide you that information to understand that. Okay, so like I mentioned, this was the last lesson where this will be a very neutral topic to cloud computing. From the next lesson, we are going to start talking about very specifics to what Microsoft Azure is by providing you an introduction to that. So as usual, guys, that's my training site over there. The YouTube sessions, that's where you're probably watching this right now. I'm going to post the slides in that location. Connect with me on Twitter. Look at the GitHub page, obviously, because I'm going to put the links and everything else, or the course asset over there. Connect with me on LinkedIn if you feel like. And thank you for viewing. If you like this video, put a thumbs up there, and please subscribe. And I will see you in the next lesson. Thank you.